You're watching to Marvelous Book, and in this episode I'm going to talk about application, general purpose, data structure and abstractions. How important are the abstractions in thinking in terms of abstractions? I have a bug lately and I see data structures in the internet world, the connections between the different blocks of information, and I also see how all this tech point of view is so incompatible with all the other areas of needed for a software and hardware product to actually be used in and be useful for a non-technical individual. But it helps me abstract things in my mind, and as such, it is easier for me to model them, to code, or to formal data structures. And I see and I think in higher philosophical, ideological point of view, maybe at some point I'll bring these abstractions to practice. I've written my point of view about data relation in the world before, and I've talked about also where the data is saved and how it relates to the super data model, the user. In this episode, I'm gonna go deeper into a little bit deeper into the code perspective and a little bit far away from the code perspective to far away from the non-tech user point of view. In architectural terms, there is not too many variations where and how to keep some data. I've talked about before, like files, like simple key-value structure of file, SQL relational database, object database, NoSQL database, graph database, and in memory. So the single file data storage are preferably used on the client side of applications or on server side for some global configuration, for example. And when the data is saved in single file, it's good to be not very big. When the information gets bigger, all the operations that are done with it will become slower, like ordering, filtering, managing, simple read and write, for example. And for this, whole systems are used that are designed to process data. Relational databases, NoSQL, object, graph, and some other indexing technology that replicates the information in multiple files. And what's that point of view help to a non-developer, to a normal user? No, nothing. The focus of a normal user is not in the low-level detail, implementation specifics of how and where data is saved. The user wants to get served. He wants to view the images of a user that he's interested in. He wants to see the successful goals of a specific football player. He wants to read his email or messages, find job, sell something on the internet, or so on. Having this higher thinking, user level thinking, it seems like it doesn't matter how and where data is saved. It does for a technical person, so to achieve speed of operations and efficiency. And while performance is relatively okay, keeping the mind in the head of a user may bring speed of speed of development, speed of extensibility and adaptability, and speed of pleasing the user. This is the one of the core things that is not entirely technical, and it is technical only for a non-developer. It is important only for a developer. For non-developer, all the technical details and implementations are magic. He doesn't care. So from a developer point of view, this kind of meta thinking in abstractions are somehow makes him go closer to the real world. This is what I'm trying to achieve lately with my prototype studio, finding the right type of application to model and to figure out the technical implementation. And I figured out the technical implementation may be changed with the time according to the speed, scalability needs, and hopefully all this will be done with my prototype studio that is creating a meta model on the data models. So my prototype studio generates code. Currently I'm focusing more on a little bit of backend and Flutter as frontend, and it creates applications based on abstract definitions, not bound to specific platform primitives. So just by replacing the builder below the generator, I could migrate to another platform that is of higher speed, like Android native or some better performing backend, better performing and cheaper. So I'm finding analogies of what I do with my prototype studio with some technologies and approaches I see and I have seen. Java, for example, started as modern abstraction of stuff, maybe influenced by Next and other software companies that started coding object-oriented software. It was 25 years ago. They detached the application development from the hardware, the operating system, the different window toolkit, and so on which it runs. Yeah, probably in many cases it is important even for a Java developer to know, but in several specific layers. All the above layer, all the business logic layer is universal, and it doesn't matter on which platform it runs, all the higher level business logic. Flutter, influenced by other cross-mobile platforms, is taking advantage of the owned by Google frameworks, is abstracting user interface and general purpose business logic from the type of device and platform. Flutter is abstracting over the user interface specifics of Android, iOS, web, desktop, and you could calculate things, you could do things and present stuff integrated with web services or some other technology, and you think how to display things to the user. You focus on how to display them and not on the specific interface components that all these platforms provide, because every native platform, Android, iOS, web, desktop, all the different versions of desktop, all they provide different APIs, and what Flutter is trying to achieve is bring them together, and the application developer to think only on how to present the things without minimizing the work to fight the platform specifics. Another colleague of mine is exploring the possibilities of Microsoft.NET Core and the framework Blazor. So very similar like Flutter, the application developers codes the business logic in C# and a mix of HTML and XML, similarly to React, and they let the .NET Core runtime or specific compilation setting decide what will be the output of all this code. It may be WebAssembly code, it could be HTML, JavaScript and CSS, plus a little bit of server-side .NET Core, intermediate language and binary, or with the help of and because WebAssembly is a LLVM, low-level virtual machine compiler infrastructure, nothing is stopping them from integrating this compiler to produce binary desktop or server-side executable files, and this way not depending even to the .NET Core runtime. So they may do this in the future. And the platform and the architecture of the way things are designed allows that. That is what, for example, that is this advantage of the platform is what allowed Flutter to try to generate web code from by passing the code to Skia, that is C++ code, and there are compilers from C++ to WebAssembly. So this is exactly the same thing as the .NET Core. It has architectural advantages that allow migrating stuff. And when the application developer generalizes the whole client requirements in terms of data structure and logic, new apps are actually a little bit, and if application developer generalizes logic and structure, identical apps could be easily generated, created, migrated, and to other platform specifics. And one such migration, I think, of implementing the same concepts, the same abstractions with different data models. This is a whole another business case that is injected with the same type of abstract thinking. What Amazon did with first selling books, then selling music and videos, and when they achieved some scale, they did know how that the code was working, and it was working for different types of categories and stuff that is selling. They abstracted to all kinds of things, and they made marketplace that achieved success. And after abstracting the host resources with the help of Netflix, they realized they implemented the same abstract thinking on resources, on cloud service, on hosting resources. So giving and by exposing these resources to API, to server-side APIs, they made resources installable to the cloud with just a few settings and tweaks, and even with the web interface with just a button. You could set up a software stack and so on. In this way, repackaging the same hardware and repurposing the code to different operating systems, applications, and so on. That's the technical advantage of thinking in abstractions. That is cool. That is that this is not going deep into the details, and when you see how things work, things start to get easy, and you don't grab yourself to the details. If some technology is super cool or not, it is not your concern, and it is not, you don't grab yourself to a fetish technology that is in the end it does not do nothing for you. But when you see the abstract thinking and you design stuff to be universal, you could migrate them and do other stuff with the same code. This is code use in very, very high level, that is beyond the code design patterns. So I hope I gave you enough examples of this higher level of thinking and why it is important. See you next time.